I just wanted to spend a little time today to talk a little bit about putting a cruise control in an older product. Um, I've done the GM style one before. These ones work really well, but they're a little bigger, so sometimes you don't have enough room to put this style of one. So I'm going to talk mostly today about the Ford style ones. So these would be the Ford style ones here. They come out of a 90s to early 2000 Ford products. I have one here is out of a Sable slash Taurus, and then this one would be out of a F-150, F-250 Navigator type. Depending on which one you want to use, I'm going to talk about hooking up the Ford one. So I went on YouTube and on the internet trying to find some information on how to make this work, and there was nothing there. So I thought I would make a little video to explain a little bit on how to get this to work well. So I want to talk about the Ford style one here. It's got a 10-pin connector. There's only 8 wires in it. So we want to talk a little bit about the outputs and stuff and the inputs from there. Let's talk about some of the crucial stuff. So the Ford cruise control is a little different than the GM one because you need resistors to make it work, where the GM style, it's just switches that cycle on and off to be able to have the inputs to the ECM. The Ford one is different. So the idea is that you can use on an older Ford product, use the steering wheel here with the off and the on and the set and the coast button. So you can still use this with this style of cruise control. So what you need to make this work, this would be a typical speed sensor that you would find on a 90s, 80s, 90s, and into the 2000s maybe. Speed sensor there goes into the transmission speedometer gear on it, and then an output. So the speedometer cable goes in here, and these are the wires that would come off for that, which would typically go to the ECM. Sometimes to different modules which are going to change that signal so it can be used for anti-lock brakes, cruise control, different things on the vehicle. So you need one of those first. These are 8,000 pulses per mile. So typically when they're at about 55, 60 miles an hour, it's about 125 hertz is what it's going to be at. So if we were to do that, we can scope that quick. I'm just going to drive this with a drill. And then watch the output on the scope here. So this is the signal in. See, it's AC waveform, and we're right on 125 hertz right now. So you can see the AC waveform. So you're going to need a little digital box like this. This one's from Dakota Digital, and it takes and changes that waveform, and it can do a whole bunch of different things. The waveform that you're going to need to make this work is going to be a square AC wave, or a square wave, not an AC waveform. So this goes plus 6 volts and minus 6 volts, but it's a square wave. You need to be able to have that conversion. So that's the first thing you're going to need to be able to make this cruise control work if you're going to put it on a vehicle that doesn't have an ECM that can change that signal. So that's kind of the first thing that you're going to need there. Some of the other important things that you need to make this work, I've kind of hooked this up into the same switch, but you need a switch, which would be, they call the deactuator switch, or sometimes it's a clutch switch. And that switch would be a normally closed, which is going to send a signal of 12 volts up to the module. And then you're also going to need a brake switch, which is normally open, and when the brake switch closes, then it sends a 12 volt signal. So both of those are inputs to help to cancel out the cruise when you're driving. So those are the two things that are crucial. I want to talk about one of the things that's very important, especially in newer vehicles, are what people like to do is put LED lights in. So if you're using LED lights, what happens is this circuit, this module sends out a pull-up voltage on that brake wire coming in, about 8 volts. So what happens if this doesn't see a ground through the brake light circuit, the cruise control isn't going to function. So it's very crucial that you actually have some kind of a filamented bulb that is going to be able to create a resistance on there. Or if you have those resistors on your LEDs, that would work as well. But it has to see a resistance, because if it doesn't see a drop in that pull-up voltage down to 0, the cruise control will not function. So that's one of the most important things to get that to work. Another crucial one to get this Ford style to work is you also need to have the power go through a relay. Even if there's no, it's not controlling anything, it has to go to a relay because it creates a voltage drop through there, which is important. Some of the newer ones like the Ford, the one for the Ford trucks, you have to actually also have a 1,000 ohm resistance in line with this that goes to here as well to make that work. All right, next thing would be your switches. So these ones came out of a 91 T-Bird. You can make your own switches. There's these ones here require a resistance. One's 2200, one's 120, and the other one would be 680. So you can use resistors in there, and they'd all be in parallel. So depending on which one you would select, it changes the voltage that goes to the module. So kind of how this works is we have the on, which when we close the on switch, it sends a signal from this voltage that's coming in here, goes through there, sends a signal of 12 volts onto the number 5 pin here, which turns the module on. And then what happens is you have to press one of these ones, which is probably the set if you were going to set that, which is going to send that changes the voltage, so that voltage that's going to be sent out from the module now, once it's turned on, comes up through here into the switch, and then depending on which one of these you select, that resistance is going to drop that voltage, send it back in through onto pin, I guess pin 6, or so pins 5 and 6 is what it's doing to do that, and it's going to change that voltage, which is going to command the module to do what, whether you want to coast, whether you want to set, whether you want to sell, or whether you're going to resume. So depending to get that. So those are the important for setting up the wires. You have a power wire in here. We also have a ground wire. We also have a pin, which is pin number 1, which goes to a can go to a lamp, which will tell us when we have set the cruise to on, which would be this one here. So those are the important, crucial parts with that. So now we kind of want to show you that once you have that going and that it works and functions properly. So I'm just going to take the power off here for a second and then put it back on. And then I'm going to put on the, get our speed signal going here again. Get our 125 hertz again. We'll just check that with the scope. We got our 125 hertz coming in. It's a little low. Got about 120, 21, 122. That should be enough to be able to get this to work. And then checking on our square wave coming out. There's our square wave. Should be the frequency is a little higher, but it'll still work here. So what we're going to do is we're going to turn on our cruise. We hit the on button, and then we're going to hit the set button here, and we should see the arm here going to move. Okay, and so now, as long as the frequency stays the same, and then what happens is if we change the frequency, so if we were to increase the frequency, you can see how it's controlled. The control is kind of controlling the throttle to maintain whatever speed the vehicle is going to be. It's a little hard with the drill because the frequency is changing a little bit more quicker than it would on a vehicle. You would probably see those changes that fast as it's going through the transmission to be able to do that. Okay, so you bump it just a little bit up or down, and then we went a little too far out of the range there. So then we could hit the resume button again, and it'll take it back into where it was. It's kind of maintaining and shifting and moving that to maintain that speed of the truck or the car, or whatever you want to put it on. All right, so I'm going to post with this. I'll post the schematic and what the pinouts are for the module. Again, you can get these from a junkyard anywhere. You can get the out of Tauruses, pickups, Ford pickups, probably Crown Victorias. You can get them. You can get them at different lengths of cable. This one's out of a Taurus, so the cable's quite a bit smaller. This one here is out of a it'll show on there. No? This one's out of a pickup, so the cable's quite a bit longer. So depend on where you need to mount it, which module you want. You know, it's a build your own cable. I built my own cables for a lot of those too, depending on what you're putting it in and where it has to be mounted. You may want to change that too. So, all right, and we're gonna hit the off button here. Turn it off. Spring retracts it, right? So just make sure it works. So thanks for watching.